Hello everybody, ODAT Nerd here, aka Terrence. This is the pre-recorded video that is going to play at the start of every Devember video. So what day is it? If you're watching this on the day that I recorded it, probably a day in December. What day? I don't know. I'm not creating 31 of these things. This is to tell you that we are working on the Devember project, which is a remote build system in Sublime Text. Now, down in the description, if I have done my job correctly, there should be a link to the playlist that has all of the videos in this series, which starts with the video that describes what the heck it is we're actually trying to build here. And this video will be a minimum of an hour long. I don't know how long it's going to go because I haven't recorded it yet. It's still November right now while I'm reading this to you out of my brain. It's not actually written down anywhere. I think that's probably easy to tell. I'm not very good at talking off the top of my head into a camera. So what are we going to be doing tonight? Don't know. Hopefully working on something really interesting, though. Probably should have thought that through a little bit more. In any case, we're going to go ahead and say the following. If you like these videos and you want to know when there's going to be more of them, subscribe to the channel, link in the description. If you're interested in videos that aren't live in nature, there's another channel I have that is going to be providing those. I have in the past and I will again. I'm just not right now because I'm doing this every day for December and it's taking up all my free time. Link to that is in the description. Like any videos that you find useful, comment on any videos if you have any questions, and most importantly, have a good time. So let's go ahead and give it to myself in the present, if you will, to continue on faceless because I don't have the sort of setup that allows me to stream my face while I'm working. Hello, everybody. Welcome to this 7th day of Devember and our little live stream trying to create a build system in Sublime for running external programs. Funny story, someone asked a question about this in the Sublime forum earlier. Well, I guess it was yesterday, I think, while I was getting ready, and I thought, that's interesting. I'm making a thing that might help that guy out at some point. In any case, what has been happening in the land of remote build system type action? As you can see from all of the colors in my sidebar over here, a fair amount of stuff, sort of. I would like to point out that after the live stream last night, as I was creating the vlog, it occurred to me that this, in the receive in the network code where I had a for range 1 to 10, like I did for send, was exactly the wrong thing. And in fact, the receive code, because it reads from the socket only one time, should in fact loop forever until it decides that there are no more complete messages. And that's just because if this only looped for 10 messages and somehow 11, the way that the data worked out, there was 1 byte missing from a message, so we waited to come around here, and the other side crammed 10 messages into the buffer all at once, and we read them all at once. If this looped 10 times, it would leave part of a message dangling, or a whole message dangling, I should say, if it managed to read all 10 of them. But because it stopped after reading 10, that message is lost, stuck in the buffer waiting for more data to come to push it out. So because the read only happens once, the while has to happen, or this has to be a while loop to make sure that we keep reading messages until messages are no more. And as I mentioned in the live stream, perhaps we want to modify this to actually insert the receive inside the loop, in which case we would have to limit the amount of times that it goes, but still make sure that it doesn't leave any partial messages in the buffer at the end of all of the loops. So maybe allow, 3 or 4 passes or 5 passes through with the read, and then after that, just exhaust the data in the buffer. But that's neither here nor there. And with that out of the way, I decided that we're probably good to continue on. There's obviously more work that could happen in this network code here. We could roll it into the actual test client command instead of having it out in its own folder, let alone in its own file here, which would allow us to trigger notifications when messages arrive. And there might be other things that we need to take care of too, like how to handle the case where a connection is lost. We're going to have to raise a notification for that, which means the close call in the connection or something along in there needs to be able to raise notifications as well. But we're going to leave that alone for the time being and move on into the server code. And I should also point out that uh, there was sort of a lengthy off-topic chat in the unofficial Sublime Text Discord, and the offshoot of which is I'm testing out the Vivala code font. Which requires me to use a slightly higher font face. Normally, you can see I normally use Source Code Pro Medium with a font size of 12. Now I'm using Vivala code with a font size of 2.25, and I'm going to close that file now that I have showed you that. But it does add some ligature support to. Oh my goodness, something looks horribly broken here. That's the topic for another day, though. Uh, what was I saying there? There are ligatures now. So notice this is the less than or equal to or greater than or equal to. And there are a couple of other things like that laying around as well. So the font will look perhaps slightly different. I'm going to try it for tonight, at least in the stream, and then I'll be able to see after I'm done what I thought of the results. Maybe I'll end up liking this font. Who knows? The discussion had talk of a lot of ligature type fonts like Fira Code, which just I thought had too many ligatures. But the other thing that I did today was spend the better part of what must have been 3 hours, including time right up to the start of the stream, working in the C# end of the operation. Now you'll recall that when we first started on day 0, I had some, maybe I'll just temporarily toggle the mini map here to make this part easier. I had this example socket code that's async and based on an example. So it listens for connections forever in a thread, and all of the operations happen asynchronously in threads. So once it accepts a connection, it can start receiving data from that connection, and then once it's done, it can it gets this read callback gets called for it to have read the data. Then we begin another receive. And when we receive certain text, we send data and shoot that across and with the begin send. And this gets called when the send is done and it closes the socket. Simplistically, it works. And specifically, if I connect 3 or 4 or 5 times to it with telnet connection, it can service each of those connections in the background without anything hanging. So it seems to be threaded in the way I want. Now, I'm not entirely sure what the best way is to do this for readability and writability. I'm imagining as a server, we want to mostly receive data and then only ever send something to the other side in response to a message that we got. But once we're running a task, we need to be able to continuously dispatch messages to the other side. Now, that is the topic for upcoming days. I'm not entirely sure what the best way to handle that is. I'm not particularly familiar with all the intricacies of this particular system, except I did do some research and determine that this seems to be the better way to do it of the ways that are available. So I decided to spend some time And we're going to go over this, and this is going to count as part of the stream because this is part of my quote unquote minimum hour of stuff. And I want to explain how all this works so that everybody's on the same page if you're watching this, but also because explaining something out loud helps cement it in your head, I find, which I believe I have mentioned before. So here is the problem that I discovered. I went looking for, I probably should not have closed that. Actually, I suppose we want this file right here. Now, you will remember that when we are getting ready to send a message, we use struct pack with a format string and some data, and that packs all of the data into a tight binary representation for transmission across to the other side, which includes prefixing when we send the message data with the 4 bytes, that is the representation for how long a message going across the wire is. And when we receive data on the other end, and a better example of that is error message, we need to decode the data by using struct unpack and providing a similar format to take the data out of the binary form and throw it into the appropriate Python data types and return it. And of course, this all works as we've seen. And there's even a factory method up here for protocol message where you can say protocol message from data, pass it a data, and it returns to you the, uh, the appropriate data by using its registry of classes that knows what the numeric ID for classes are. This is how I chose to implement this here in this code. So we're going to need something like this in the C# side as well. So I went looking, what is the way that you would take binary data and convert it into native types? And how would you take data from native types and convert it over into a byte array so that we can transmit it across to the other end? And how can we take that, data and decode it? And I discovered that the answer to that is the functions in the bit converter class. And it has a couple of types of methods, as you can see. One is you can give it a byte array and an offset into that byte array. And the method that you call determines how many bytes it's going to consume. And it consumes that many bytes and converts it into the appropriate format. So a uint32 is a 4-byte unsigned integer. So this is going to take the first 4 bytes from test starting at offset 0, turn them into a uint, and return them. And the analog to that is get bytes, wherein you pass it a value and it turns it into a byte array for you. Now, what I discovered here is, which makes me sad, is that the bit converter class, it knows whether it's big endian or little endian. It knows that based on the platform that it's running on, but you can't tell it to perform conversions in a certain way. So because this Linux box is a little endian machine, bit converter to uint32 always takes the bytes out, assumes they are in little endian, and uses that in the conversion. And you'll recall that when we transmit our messages, we are forcing network byte order by using a greater than sign in all of our unpack froms and our pack twos when we pack messages. The examples of those are down here. And we're doing that in big endian format because that's a network format. It's another name for that. And it's important to us that in order to be platform agnostic, we need to send the data in a known format. Because if we just sent it in the native format, then if the one machine was little endian and one machine was big endian, they would both have issues talking to each other, right? So we are transmitting everything in big endian format, which is an issue because the bit converter class always assumes a certain endian, and even worse, it's not even the correct endian, let alone uh, you know, not being able to do anything. So I spent a bunch of time looking at that, and basically what I found was what you should do is do your own conversions where you reverse the order of bytes in the array depending on what format you want the data to be in, and then use bit converter. And I also discovered as a result of that this particular library here by John Skeet. I'll go all the way up to the top here, which is his Miscellaneous Util library. It has a fair amount of stuff in it. It's actually written for .NET 3.5, but it seems to work just fine in .NET Core, with the exception that some of the methods are not. And actually, I think that was actually methods in the bit converter class as well are not CLR certified or whatever the term is, basically because they I'm dealing with unsigned types, and apparently the Common Language Runtime doesn't allow that for certification purposes, because I imagine maybe Visual Basic or some of the languages in this that are supported by the CLR don't have the concept of an unsigned number, an unsigned integer or something. In any case, it seems to work just fine. And instead of trying to compile it myself, I investigated using GNU Get because John Skeet's miscutil is totally available here. Now, confusingly enough, here it's listed at 0.2.0 and last updated in 2017, whereas over here the last releases are 285 on February 26th. I didn't do any investigation to see how much newer or what the changes might actually be. I just, went ahead and installed it. And there was some arcane or semi-arcane argument to get it. I guess actually that one right there. I ran that command, and the result of that command was to add those lines to the item group. Specifically, it added this package reference into this item group. Actually, I think it actually added the whole item group itself and an empty tag for package reference to mention that. It also rewrote this file to be a DOS file, which I found mightily annoying. And then after I built it a couple of times, I went and looked up this line here to add because this warning warned you that the thing was unpacked with .NET Framework 4.56 or something like that, even though it specifically mentions that it's using .NET 3.5 and I'm using .NET Core 2. It said that maybe it'll work, maybe it won't work, but it seems to work just fine, at least for the little bit of that I'm using. So putting this line in here shuts it up. And with that, I went ahead and started working on just verifying things. So we're going to run the test here, and just for the purposes of this, I'm going to uh, comment out this bit here because that's a separate type thing, and I'm going to save the file. Now, here's what I did. I chose this number, 12345678890, because it's really big and fits into 4 bytes. And then I went into this bad boy here and did struct.pack. And then I probably did something like that, and 12345678890, and got some result. Oh, what would I have done there? My gosh, that's the wrong one. Let's go ahead and close that and bring this back just for our own edification here. Really seems like that is the thing that oh, sorry, it's I think it's an I. In this example, H is for the message ID. That's not what I did here. And I came up with, that. and figured out what those bytes actually are. And in order, they are these bytes, 73, 150, 210. Then I created a little endian bit converter and a big endian bit converter, which come from that John Skeet Miscutils library. It is essentially a class that is identical in function to bit converter, except that when you create it, you tell it what endian you want the data to be converted to instead of it determining probably not the one that you want it to use. And then we just do a little simple test. We're going to show what the actual number is. We're going to see what the bytes look like, and then we're going to decode it first using bit converter, then little endian and big endian converter, and then we'll go the other way and take this number and turn it into a byte array and see what falls out of those. And I'm going to go ahead and also comment out that, and we can also see this is the magic of some ligatures in here, making this arrow look all quote unquote fancy. So if I run this bad boy and I've done everything correctly, we see this. The input number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 with the bytes 73, 150, 2, 210, just like there. Now, if we use the bit converter to convert those 4 bytes into back into a 4-byte unsigned int, we end up with the number 352.338.4905. And you'll notice that's the same as the little endian bit converter comes up with, but the big endian bit converter comes up with the correct number. So that is just a verification that the little endian and the big endian one comes up with different values, and the bit converter is definitely doing little endian type stuff. And if you were unfamiliar with how endian works, this is the other example of that. Here is the taking this number and turning it into a byte array. And that means it's taking, this is a 4-byte integer, so it's taking each of those 4 bytes and splitting them apart and storing them in an array, right? Bit converter comes up with 210 to 150, 73, which as you can see is this one backwards. And little endian comes up with the same number as that one, and big endian comes up with the number we had up there. Now, this points out that the difference between big endian and little endian is which side the least significant byte is stored on. In one, the least significant byte is stored in the right-hand side, and in the other one, the least significant byte is stored in the left-hand side. And whether it's big endian or little endian, that's how that works. Now, 1-byte numbers obviously don't have endians. If it was a 2-byte number, then those 2 bytes are backwards. It would be 73, 150, or 150, 73, depending. 4 bytes, the whole array goes backwards. 8 bytes, the whole array goes backwards. Right? So this is proving that we can, in fact, decode those values. Now, the next thing I wanted to look up was how might we do something where this is going to be decoding the byte array into local values, and this is going to be encoding the byte array or encoding the value into a byte array for transmission to the other side. So here's something that we also might need to do, which is taking data from one buffer and copying it into another, or sort of the joining of two things together. Now, I did some research in this, and it seems like, unlike Python, where you can use the slice operator or the append to stick one buffer onto the end of the other, in C#, the faster way to do that is to use a block copy, which I guess would indicate that the best thing to do is either have an array that's big enough to start with to grow into, much like you would in C, or maybe make a new one and block copy things in. I don't know. But in any case, because when we transmit messages to the other side, we're going to need to first encode the message into a block of data and then prefix it with the length at the start, or figure out what the length of the byte array is going to be and come up with a list that big plus some extra, I wanted to know, how to do this. So here we create a new 8-byte array, which fills it all with zeros, and we're going to see that there printed, I would imagine. And then we're going to block copy. This goes source offset, destination offset, and number of bytes. So from the test array at byte 0, which is this one, into the array I allocated there in the second position, so the third byte in, copy 4 bytes. So those 4 bytes should appear in the middle, and there should be 2 zeros on the left and 2 zeros on the right. And if we go ahead and run that and check out that test on the bottom, we can therefore see there are the 8 zeros from when we allocated the buffer. Those are our 4 bytes copied in. And also, if we use the big endian encoder to get a converter to get a uint32, an unsigned 32-bit integer from my array at position 0 or position 2 instead of position 0 as we do up here, then the result is the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, which is that number, which proves that we can successfully snag those 4 things out at position 0, 1, 2 for 4 bytes and come up with the actual number. Now, the harder part and the thing that I spent the most time on, I want to say an hour and a half, maybe 2 hours, researching and playing around. This is the culmination of that. Now, this is a very simple example that just tests message dispatching, if you will. This is the equivalent of being able to call protocol message from data and have an appropriate message fall out. So instead, we're calling what I just called message factory from data and passing it one of these byte arrays. Now, this would actually, it should be a full complete message, but it's not for right now. It's just single bytes, where that first byte is the one that's being used to determine what's what, because this is test code. And based on that, we try to create 3 different messages. One for message type 0, which we know is introduction. The second for message type 1, which we know is error. And the third for message type 2, which does not exist. So that's going to test what happens there. And then we say we're done. And now that that code is uncommented, if I was to run this, we can see it says it's creating an introduction message, which is that one. So that worked. It says it's creating an error message, which is the second one. So that works. And then it threw an argument out of range exception. Specified argument was out of range of valid values. Now, I did some research on this. What exception should you throw in that case? And, consensus seemed to be from the stuff I was looking at, there is technically a range of values that's valid for that particular argument, if you will, if you could call it an argument, because there's a defined set number of messages, right? So it goes ahead and throws an exception there. Now, that part, of course, is fairly simplistic, but how it all came together at the end, let's go ahead and zoom in. This thing here, this is the part of C# programming that, if you will, vexes me a little bit. Because I have a lot of experience in languages like C and languages of that ilk, so the syntax doesn't bother me, but there's a certain mindset you use when you're writing C code, or even to a certain level C++ code or Objective-C code, which is what I tend to write the most, or historically have in my job. But C# is very much like Java in how you would go about designing your code and laying everything out. And sometimes I have a hard time wrapping my head around that. So I spent some time experimenting with how we might get something similar to the Python code into this. And this is what I came up with, and I don't know that it is particularly clean. It could probably do with a lot of cleaning up. But the general idea is this. There's an enumeration that lists what all of the message types are. And as far as I can tell, the size of an enum is a signed 32-bit number, or at least it's a 32-bit. But yeah, I believe it's a 32-bit number, if I remember correctly. It might have been a 2. In any case, the size didn't concern me that it was going to be either too big or too small. And we have to define these messages in the same order that the Python code over here um, did so, by dint of having each of those classes have its own message ID value. Introduction message is 0 and error message is 1. Over here in the Python code, it's this class that's deciding it. Over here, it's an enumeration. Then we create an interface that all protocol messages should support, and the only one that it does support is or that is absolutely necessary is encode. Take the state of this object and turn it into bytes. And then we have the message factory class, which we saw me using with a static method that returns something that implements iProtocol message in an argument named from data with the bytes. And as a short circuit, because we're not actually doing anything of any great import here, we can see that we're just using the first byte in the data, just so I wouldn't have to pull in that decoding stuff from the other file, into a uint32 message ID, and then casting it to be one of the elements of there, which seems to be necessary because maybe this is the case in new C++. It wasn't back when I was using it a lot. An enumeration and an int are so strongly typed that it tells you that it's not going to do the implicit cast that it knows it could do and wants you to do it yourself. So I just, threw the typecast in like there. And here we can see if it's an introduction message, it creates a new introduction message from the data. If it's an error message, it constructs it that way. And otherwise, it throws that. And then down here, we have the introduction message implementing protocol message with its encode that currently does nothing. And the constructor, the single constructor, takes a byte array and is going to be responsible for decoding stuff into here. And similarly for error message. Now, I'm not fully happy about this because I would really like this interface to specify that basically the thing that implements it needs to provide a constructor of type byte array, just to make it implicitly clear. Because if you skip this part out, if this code wasn't here, then when you compile, you get an error that says introduction message doesn't contain a constructor that takes one argument. And if you were to actually look at line 28, you can see that it's calling it with one argument, and that one argument is byte star. So you would infer that you need to create such a constructor here. But the error message sort of irritates me. It seems like that should be something that you can do. Um, Maybe instead of a interface, it should be a class. Instead, it should be a protocol message class instead of an interface. And then it would have such a constructor. I don't know that you can necessarily force a constructor override, but it would be absolutely necessary in that case. These are the sorts of design things that I'm not sure what the best way to go in C#, even less than I'm sure what the best way to do the same thing is in Python. So this is what we have come up with. And I guess the downside to this per se is that now the mapping for what message type associates with what class is spread out. There's an enumeration that provides the numeric values, and there are classes that do something, and in the middle is this enum in this from data static thing in this message factory that uses that enumeration as a hard-coded thing to know. So it's not as straightforward to add a new message like it is in the Python one. Now, Python is more of a dynamic language, and maybe this isn't even a good way to do this. Maybe this same thing should be happening over here in the Python code. I don't know. But in any case, that is where we are right now. So the plan for today was to implement this and see if we can get it on par with the messages here, that is encoding and decoding appropriate messages into its appropriate fields. And we've gone part of the way before the stream. That's why I wanted to go through all of the logic there before we start in proper here. So that's a good 20 to 25 minutes of the stream. But if I wanted to convey the learning process here, because I certainly, this is like iteration 20 on various factory protocol type things that I was looking into, including trying to do it the same way as in Python, where there would be something that could try to associate a numeric value with the name of a class and use activator create instance over here to actually call the constructor for the thing, which seems to be fraught with all kinds of peril and ugliness. So, like I said, as much as I don't know what the Pythonic way to do something is over there, I'm doubly clueless about C sharp. So this ought to be interesting. Now, um, at some level, we're sort of good to go here. For the purposes of this, let's maybe try to implement this a little bit. Or, you know what, actually, before we start, what we might do here, um, sorry, I need to look at the main stuff here. That's the call that used to start the server listening. I'm going to, just for our purposes here, comment out, let's say that part, and we'll also remove the obviously broken one like so. So if I was to run it now, it says we're creating those two types of messages. Now, excuse me, over here, if I just zoom that one for a second, this is the Devember one, so that's not the one we want. We actually want net test network, this one here, and jump down to the bottom. And I think what we want to do is say message 1 is equal to introduction message and message 2, oh, sorry, dot encode. And this is something I was going to try just to see. So maybe I'll try it once before I go ahead and do stuff and say return. So, whoops. Oh, yeah. I got to switch the build system back to, well, I'll just go ahead and set Python 3 specifically. And, oh, you can't do that, huh? Can I break? Oh, I guess I probably just have to comment all this stuff out. Well, we can revert it later anyway, that's okay. And go like so, and it's finished. So the goal is to print it as a list of items. Yeah, good. Instead of as the byte array version of it. And here we might also do the same thing with error message. And remember, when we construct an error message, we need to provide the code, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and a string. I am the error message, and I'm some number of bytes long, like so. And we'll also print message 2. And when I run it, Oops, my bad. Throw a dot encode on the end. Okay, and we probably want to temporarily turn word wrap on. Now, if I copy both of those, which I currently have to do with the menu item because I set up key binding, so Control C cancels the current running build if the output panel has the input focus while I was working on the other stuff, and it caused no end of issues. Now we'll say create buffer C sharp, prompt for syntax C sharp, my bad. Throw that stuff in. And what might we say here? Byte intro is equal to new byte, and that I think would be 1. And if we also said byte errors, new byte array of that, and perhaps I might also go ahead and do a little something like this just to make it a little nicer to look at. That's actually not the right amount to do that, but that's probably okay. Did I not set the syntax to C sharp? I wonder what the deal with that was. Well, file manager commands is certainly doing some dumb stuff sometimes. Okay, let's go ahead and cut that and come over to here. And throw some indent on them. And again, like I said, that's actually not the correct indent, but that's okay. So now we have 2 different types of messages that we could attempt to do something with. And I might say var message is equal to message factory from data intro, like so. And similarly, this one would be error, but we'll comment that one out and do that. Now I would imagine I can close that, and we want to actually, oops, net test messages so that we can refer to the stuff over here, and we'll just zoop that over a little bit. Now, let's see what we can come up with here. First of all, protocol message should have a protocol version. And maybe I better change the build system back to the one that's shipped here. Public protocol version. What might we call int, I suppose? Just so that it has a value. Now, does that still compile? Because do I trust myself? The name info does not exist in the current context in 275. Oh, did I bust a little stuff? Intro. Whoops. Shoosh. Okay, so that seems to be okay. So that's going to be the protocol version. Now, we don't actually technically need an introduction message here on the server side because the conversation is going to be started by the client, and the client's going to tell us an introduction message, and then we introspect the value in it to know what protocol they're speaking, and then we modify our own behavior or throw an error message back. So technically, we don't really need to try and encode one of these messages. We only need to decode one of these messages. But let's go ahead and ignore that for our purposes here. Now, this is actually, I think, fairly simple. because the protocol message, as we saw here, is 3 bytes. The first 2 bytes are the big endian representation of the message type, which is 00, and the last one is just the protocol version as a single byte. So actually, is there a int1? C# byte types. I guess just byte is unsigned. Okay, that's more or less what I would have expected. So maybe we change that to byte. Oops. We might actually say get private set because we're the only ones that should be able to screw around with it. Should still compile okay. Now, we maybe want some sort of verification here, but just for our simple purposes, we might say protocol version is equal to data 2. And that's really all we got to do there. And this would be 00 and protocol version. We don't even need to encode this one because it's a byte. So that's still, ooh, that's unhappy. Did I forget something important? Maybe you're not allowed to do that. Whoops. Invalid expression term on line 53. Oh, you're not allowed to do that, huh? Can I do that? Oh, sorry. This is a this language. I suppose that's not cool either. No. Byte v is equal to protocol version. No? All right. Well, I guess we have to say byte message is equal to new byte 3. And message 2 is equal to protocol version. And return message. How about that? Does that make things happy? Okay, that one's okay. Who knows? Maybe because that's a property, you're not allowed to do it in an initializer. I'm pretty sure that based on the example over here, when you initialize a new thing, that it gets, this one here ended up with 8 bytes that are all new or all 0. So I assume that's probably kosher. So this should allow us to encode and decode a message. And it'll accidentally work. So we actually need to print the appropriate message. And I'm not sure what the best way to do that is either. That is good, right? So it's an introduction message. I'm going to go over here to the window where you can't see and type C# to string. And click on how to override toString. When you decide what information to provide through this method, consider whether your class or struct will ever be used by untrusted code. Be careful to ensure you do not provide any information that could be exploited by malicious code. Okay. Public override string to string and return introduction message version equals that I probably want to return string.format if I had to guess, and protocol version. And maybe I might even be smart enough to close my little tag there. And okay, that is pretty good. Now let's say C# exception for array too small. Well, array. Let's see this. C#, what exception type to throw if a list connection is empty or null and can't be iterated? Ba. Create your own exception type. No reference exception. The other issue with code that throws exceptions might be what exception you choose for any given point. Invalid, yeah, I guess invalid. Oh, that's the same thing that I came up with the other day. Argument exception. Exception that is thrown when one of the arguments provided to a method isn't valid. Okay, so what we actually want to do here is say if, oh, not that one, sorry, this one. If data.count is not equal to 3, there's our yeah, I can never remember whether it's count or length. Possible mistaken empty statement. Yeah, there's a ligature there. Ooh, that's exciting. And there's one there. Does this make this code easier to read? Throw new argument exception expected 3 bytes. Let's say message data length is invalid. That provides us a little bit of extra security blanket, if you will. Now, if I was to modify this like so, we get that because the first byte is still 0, it's only using 1, so now it thinks that this is an introduction message. So the first thing we need to do is actually pull that value out, which is going to be not encoding the byte array, it's this one. And the downside to this is there needs to be, I don't know what the best way to do this because it's apparently something that you need to construct as far as I can see. And you only ever, well, I'm only ever going to need like one of them at a time. So I don't know what the appropriate thing here would be per se. Now, if there is actually, there's not actually a base class, there's just an interface. If there was a base class, its constructor could create one of those things. So for our purposes, let's say new big endian converter, we'll copy this line. And it goes up here. And it is a uint 32. No, it's a uint 16, actually, I think. It's going to be 2 bytes. Can a C# class have a static member? C# static member variable. And yeah, I know what the keyword static is. What's the use of a static variable in C#? When can I use it? A static variable shares the value among all instances of the class. Example, without declaring it static. So maybe one way we could do such a thing is say public converter. I'm not actually sure what the base class of that is. I'm assuming it's bit converter, but we'll find out. Bit converter is equal to new big Indian bit converter. What does that do when I build it? Anything good? Can't declare a variable of static type bit converter. Oh, maybe I can actually say that then, because I don't know what it's. The typer namespace. Oh, whoops, I forgot. I need to pull that in. Anything else in there I need? Probably, but I'm sure we'll find out soon. Okay. Pull a little of that action. Okay, so now we're gonna assume something similar to this here. If data.length is less than 2 that, because we're going to need at least 2 bytes in order to shoot through here. uint16 is going to be converter.toUint16 data 0, and then it converts it. And probably in this case I could make this smarter by doing that and leaving that part out. And does that build? An object reference is required for the non-static field. Oh, I forgot to put, oops, that probably needs to be on this side. That's unfortunate because now it probably won't compile because you're not allowed to create a constant class instance or something. Okay, so now it should say creating error message, I would imagine. There we go. So now it's successfully detecting what sort of message that it should be creating down here, which is a good. And as a matter of fact, we might do this and copy that to there, or cut that to there, and cut that to there, because we don't care about either of these. And then if we ran it, it should create a couple, an introduction message of version 1 and creating error message. That's just something in the constructor, and the toString says error message. So we've got something going there. In the error message, the fields are an error code, and we need to know what size those are. So let's go ahead and, whoops, do that. And again, the H, if we were to look at this, is the unsigned short, which is the 2 bytes, which is a uint16. So that part was obvious. And then the next is the length. Oh, hang on a second. The pre-length is that. So we're pulling out that, the code, and the message length. Oh, sorry. That's getting the message code and throwing it away, getting the error code, and getting the message length. We don't care about the message length per se as a field, but we do care about it here, and an I is an unsigned int4, which is a 32-bit number. So public uint32 error code equals get private set. Oh, sorry, that's not how that works. Start off with an empty error message and public string error message, I imagine was what it was called. Well, yeah. Get private set is equal to none. No, it's equal to null. I think that's mad because of, whoops, that, and that's mad because of that. Now here, we also need a uint32 message length. And here's where maybe there are some potential. Okay, let's first of all remove that. And if we do this and throw it down here, and this was error message, and this was code equals and message equals 1, and then we add error code and error message. That should, I think, blow up in our head. Member names can't be the same as their enclosing type. What? Oh, crap. Well, maybe say error code and error message. I wasn't thinking there. Error code, error message. Maybe I don't even like that. Maybe I would say code and message. Maybe that's nicer. Whoa, what the hell happened there? Okay. That seems to be mostly okay-ish, declared but never used. Let's consider that, no problem. And it's a message with code 0 and that. Okay, so this is the thing that's encoding it. So we can go ahead and zoom that. Now we know the size, and we know we're going to have to pull a length out. And we're going to need message factory dot encoder. Is that, oh, I've already forgotten. Message factory dot converter. Let's go ahead and type that right away. Whoops, wrong spot. Message factory dot converter is the thing that we care about. And now we know that the first 2 bytes are the code. That's us. Something's already decoded, so we don't give a patoot about that. Then the next thing is the error code, and the next thing is the message length, and both of those are uint4s. So we might say if the data length is less than what? If it's less than 2 bytes for the message type plus 4 bytes for the error code plus 4 bytes for the length of the message, which is 10, right? If it's less than 10, then the message data length is invalid. There's not enough data for us here. Otherwise, we know that the first thing is the code, and we might actually scoot that up there. Well, actually, maybe we might not. Maybe we might put it here. And we might say that the code is equal to the message factory converter. And what are we calling that with? We want 2 uint32. Okay, so it's not a function, it's 2 uint32 from the data at offset 2, because the first 2 bytes are the message type. And this is equal to the message factory dot converter to uint2 data. And 4 plus 2 is 6. Now, these are magic numbers that one person might not necessarily like, but nevertheless, that's getting us the message code and it's getting us the message length. Now, unfortunately, this is the part where we have to say if data.length is less than 10 plus message length, then throw another exception. Just the way this is structured, because we need to know there's at least this much to be able to figure out the length, and then we need to verify that there's enough bytes for the length as well. And for the other part, we need to look at what I did in the receive callback over here. We encoded it, I imagine, as UTF-8 over here, because that's how we roll. Yeah, so we want something akin to that. And we can jump back over to here and say message is equal to encoding UTF get string from the data at position 2 plus 6 plus 4 is 10. The first byte after the 2 bytes for the message type, the 4 bytes for the error code, and the 4 bytes for the length of the message. And the number of bytes to get is message length. And we're done. The name encoding does not exist in this context. So this is, I'm guessing system.text is the thing that I'm missing. Here's another thing that irritates me. It really wants to use UTF-8 with BOM. I don't know that UTF-8 needs a byte indicator. We'll push that up there. That happy? Argument 3 can't convert from uint to int. Really? Ah, boy, 92. What if I did this? Okay. That's a distressing property, but nevertheless, if I run it, the error code is 123456789 and the message is I am the error message and I'm some number of bytes long. And it seems to have properly encoded that message or decoded that message. Now, we already implemented the encode here. That part's simple enough, right? That's that bit there. And that's very easy to do because we know that the first 2 bytes are always going to be that. Now, how are we going to do it here? And what I'm specifically thinking of is encoding. Is there something that tells you, well, that's the derived class, the methods for encodes a set of characters into a sequence of bytes, but what I want to know is how big the bytes are. And I don't want a max byte count. I want to know the actual bytes, which is kind of unfortunate that it can't. I guess the only way to do it is to actually encode it as UTF-8, right? So that may make things somewhat tricky per se. So, well, no time like the present. Okay. Byte header is equal to new byte. And how many bytes do we want? 10. We want 2 bytes for the message length. We want 4 bytes for the error code. And we want 4 bytes for the length of the string. And then we want to say byte. Oh, maybe we actually can do that smarter. Message bytes. If we do it this way, we don't have to do it that way, perhaps. Is encoding dot utf8 dot get bytes for error message. I assume that's how that works. You pass it, oh my goodness, from the specific string into, oh. That's smart, huh? The index of the first character to encode the number of characters to encode. Is that what I did over here? I don't remember being annoyed by that before. We read data. When it's time to write it, get bytes data. It's just a string. So yeah, there must be like an override for that. Maybe I just didn't look close enough at all of them. Or some of the arguments are optional. Returns the actual number of bytes written into bytes. I'm not going to lie, I'm a little confused at how this and this jibe. But well, let's see what the compiler has to say. Oops. We want this one. Message byte is that. And okay, what if I compile it now? Error message is a type which is not valid in the given context. Ah, man, how many times are we going to do that? Message. Okay. So that seems to work. And this is new byte 10 plus message bytes dot count. And let's say return, well, we can call it message now. We don't need to call it that. And that still compiles. No, it doesn't. It does not contain a definition for count. That's right. I've already been through this. Length. It is entirely confusing that between all of the languages that I use on a daily basis, some of them use strip for some things and some of them use trim for the same thing. Some of them use length for one thing while the other ones use count for something else. And sometimes the state of those two things is inverted and blah. Okay, now we need to cram some data into a buffer. And the example of that is one of these things. Encoding the byte array, 2-byte string, and it's still this, and we actually want copied. My good gracious me. Oh, this one. We want that line and that line are the two things that are probably interesting to us here. So, except we don't want to use bit converter, we want to use message factory dot converter dot. We don't want 2uint32 because that's taking the data out. We want the opposite. Oh my, did I not have an example of how I might pull something like that off? Oh, no, yeah. That's that one. Get bytes of the appropriate thing. Oh, okay. And you got to try and copy them in. Okay, so let's copy that too. That's probably not too terrible. So what are the actual things that we're actually try to store? We're going to store uint16 message type is equal to uint16 of message type dot error message. I think it's just message type dot error, to be perfectly frank with you. Yeah. Maybe that will compile. Then the next thing we want is a uint32 code, which is, well, I guess that's already a property, so that's not something that we need to put here. Maybe we don't need to do that if we cast as well. And we definitely want a uint32 message length. Maybe we actually, no, it's equal to message bytes dot length. Maybe we'll do that. And then this can be message length and it looks nicer. So the message, take the message, convert it into a byte array, get the length of it, stash into a variable, because I'm not entirely sure how this works behind the scenes. I don't know if it's a reference or not, and we can always clean that up later. Now the actual message is a byte array that's 10 bytes plus the message length, and we might actually say 2 plus 4 plus 4 plus message length, just to make it very clear that the first 2 bytes is the message type, then the next 2 is the code, then the next 2 is the message length, and then the rest are the bytes. In which case, if we said message factory dot converter dot get bytes, and the bytes that we're getting are first the message type, and we'll go ahead and comment out that. Now let's do this twice just to see. If I said message type dot error and actually threw a uint16 on this thing, would this actually compile? Cannot implicitly convert int to uint. An explicit conversion exists. Are you missing a cast? On line 98. Of all places. Yeah. Okay, so we can actually do that. So we don't actually maybe need to pull the message type out. So we get rid of that. So what are the things we're putting in? We're putting in the message type. We are getting bytes for message length, which, so we're getting bytes for the error code, which is a uint32, so we don't need to do anything. We are getting the bytes for message length, which we had to pull out into a variable so we could use it here in that one. And those are the only things. So now again, before we get too far down the line, that's good. Now these are giving us byte arrays, which is something that we need to use buffer.block copy to do something with. Source, and this is hella ugly, but you know, make it work, then make it pretty. Buffer.block copy. From that, at position 0 into message at some offset. Now, the message type happens at offset 0 and is 2 bytes long. The message code happens at offset 2 and is 4 bytes long. And this one is the message length, happens at offset 6 and is 4 bytes long, allowing us to buffer.block. block copy from message bytes at 0 to message at 10 and return message. And ooh. Oh, I forgot to add the sizes. 2 for that, 4 for that, 4 for that, and message length for that. Cannot convert from uint to int at line 109. Let's just double check that. Argument 5. 1, 2, 3, 4, 5. Yeah, that's still not distressing. Let's go ahead and use a signed number for the number of bytes to copy, because it totally makes sense to copy minus 3 bytes. Oh, sometimes signed and unsigned is a worse virus than making things const, though, if you're unfamiliar with the const virus. And build that builds, and I mean, it's going to run because we're not actually doing anything, right? So the next state of affairs, and maybe we actually want to do this up here in protocol message. Block copy, get bytes that for message type introduction at 0 into the message at 0 for 2. And then that is just that. That's just so that we can definitely see this. Now, I imagine, again, if there was a base class here, a protocol, if instead of iProtocol message, there was just protocol message, then there could be a very simple method that assumes, takes care of, you could call maybe block copy, and there could be like a bunch of methods or something. That's, to be honest, I don't know, but this is some pretty ugly stuff. Maybe I could create a alias for that static things to make it a little easier. That might not be too ugly. But in any case, what if, okay, we can actually get this, but we can't set it. Which means if you construct this message with no arguments, would you actually decide the protocol version was supposed to be 1, right? Like so. Yeah, it's 1 by default to start with because it's version 1. Whoops. So there's no way to create one of these except for doing it that way, which is what we want. We don't want to be able to specify. We want this code to know what the version is, the same as we do over there. But we'll be able to test that it encoded because it's pretty simplistic to know that if that all worked. And here we might also want a public error message, and we might want a uint32 code and a string message. And in such a case, we might say code equals code and message equals message. And I'm presuming that that isn't breaking things too much. So if we came over here, instead of doing that, what if we said byte intro is equal to new introduction message dot encode, and byte error is equal to new error message, and the error code is 98765432210. And the message is blast off dot encode. And these were commented out. The typer namespace. What if I actually spelled it right? What about that? There is no argument given that corresponds to the required formal argument data of introduction message byte. Oh, I guess there needs to be an empty constructor in that case, huh? Okay, how about now? 274. Cannot convert from long to uint. Oh, maybe it's too long now. Okay, good enough. And the result is still an introduction message with version 1 and an error message with code 987654321 with the message blast off. Now, maybe for our purposes, we might say UTF-8 multi-byte character example over here in this search. And maybe we could find something that had an example of a UTF-8 character that has more than one byte. I'm pretty sure I've tried stuff like this in the back. The Unicode point for the euro. We'll throw one of those there and one of those here, let's say. That seems still to have worked. So at some level, we have constructed our own ability to do that. Now, just to verify, I don't know if this is strictly necessary, but if we change this to 10, then when we do this, we get an introduction message of version 10. And maybe just for test purposes, that could be error, so that we can verify that whether we create it ourselves or get it from data, we get an appropriate version of the protocol in there. So that is what one might refer to as some modicum of success. Now, this code is obviously ugly as sin currently, but that's neither here nor there. I think this proves that we can take binary messages and decode them into something, and we could create messages and encode them into something. So unfortunately, I think that means that for tomorrow, what we're gonna try to do is modify this code so that right now it's acting as an echo server, and the echo server nature of it is to read a string, and when it gets the string EOF inside less than greater than signs, that's what causes it to send the data that it's been buffering back. So maybe we start in on the ability to turn this into an echo server that reads data, and when it sees a complete message, it can echo that message back. And just to test throughput of things, we'll decode the data into an instance and then re-encode it to transmit it out, just to verify that that mechanism works. And if we get things to that level in the next couple of days, I don't know how long that part will take, then we can go ahead and link the network code from the messages.py and the network nettest.py code into the plugin and start with what we had on day 0 or day 1, depending on how you look at it, where we can hit a key and send a message and get it popped back up, only now it's using our network code and protocol. And once we get that sort of going, then we can really dive into the meat of this actual build system. We'll have laid maybe not all of the groundwork, but enough of the groundwork to be able to communicate between Sublime over here and the server over there. And then we worry about how do we take the files from here and ship them to the other side? How do we launch the program on the other side? How do we transmit the results back? All that stuff. As you've seen in all of my live streams and in these Devember streams, I build things up in a sort of iterative fashion because realistically, thinking of all of the things that have to happen to make a build system like this that can talk across the network and do stuff is kind of daunting. And I'm kind of, despite the fact that I've thought about it a lot and how I want to do it, it's still a monumental task. And you kind of freak out about it a little bit. So just chew away at the edges and get the easy parts done. And now there's less things to do. Pick another next easy thing and continue on from there. So that is what we shall do. And I'm going to call this stream to an end right now and follow the standard protocol whereby I will record a vlog, get it off the camera, get it encoded and uploaded to YouTube, and then come back here and commit this code and throw it into the repository. And what state will it be in the repository? Uh, Probably, I'm guessing, very similar to this because there's going to be a lot of stuff that needs to happen. And until we're relatively assured how we want this to be structured, I don't want to spend too much time trying to clean up code that we might end up not keeping, um, despite the fact that this is some kind of ugly. Maybe I might actually factor it like so that at least it doesn't look as awful. Um, but or maybe I could create um, an extension method, much like this one down here, for turning a byte array into a nice string of things instead of just saying byte array. But that is all we have for tonight. I have gone 22 minutes past my 1 hour thanks to that 20 minutes I spent explaining what I was going to do. If I had just dropped in and started working on stuff, it would be 22 minutes in the past and we'd be at the same point, but you wouldn't understand how we got here and how it works. So thank you for watching, and we'll see you on the flip side. Make sure all of you have a sublime day.